We are now moving on to lesson 2 from the unit Numbers and Exponents, and this lesson is found on page 7 of your workbook. A couple of things, I will probably do this lesson in 2 to 3 parts, just because there's quite a bit to it. So I'll do this first part now, and then I'll assign you some homework. Once you're good with that homework and everything's right, then you could watch the second part, so on and so forth. What happens in math is you really need to understand the concepts from the last lesson in order to be able to do this lesson. And then you're going to have to understand this lesson in order to be able to do tomorrow's lesson. So it very much works that way in math. Normally I don't do these review questions, but I will do it since it's video. And if you want, you could fast forward through it, or if you want to make sure that if you want to check your understanding from the last lesson, you can do this with me. So the number 48 and 72, we have to know this concept and be able to express it as a product of prime factors, and we need to be able to know that really well for today's lesson. So how we did that, I'll do the number 48 with you, and then I'd like you guys to pause it and do 72. But remember, we always write the first few prime factors, so 2, 3, 5, 7, 11, 13, 17, 19, 23. And you take the number that I give you and you always divide it by its lowest prime first, so 2 and 24. And you stick with the number 2 until your number is no longer divisible by 2. So 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. And I'm completely done the number 48 because this last number is a prime number. You always have to go until that last number is a prime number. So then if I was to write 48 and express it as a product of prime factors, or what's called prime factorization of the number 48, it would be 2 times 2 times 2 times 2 times 3. Don't forget that last guy. That is an expanded form. Exponential form would be 2 to the power of 4 times 3. Okay, so that's how you would write 48. I want you guys to do number 72, and you could pause the video and then you could check my answer. Okay, so let's do 72. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 is not divisible by 2, so jump up to 3. 9 divided by 3 is 3. Circle all of your prime factors, and 72 expressed as the product of its prime factors would be 2 times 2 times 2 times 3 times 3. Written in exponential form is 2 to the power of 3 times 3 squared. And again, if I was to check on my calculator, so I bring out my calculator, 2 to the power of 3, scroll down or out, times 2, here's your squared button. And that should be 3 squared, sorry, times 3 squared. And let's see if we get 72. If you get that, I know that my answer is correct. Okay, what this lesson is on, we're going to need to use this skill here. But what we're doing essentially in this lesson is like, what's the point of doing this, right? What's the point of writing numbers as product of prime factors? This lesson is all on something called applications of prime factors. So when you guys were in junior high, you learned something called GCF. So I want you to highlight this term GCF. I'm going to show you how your grade 9 teacher would have done GCF, and then I'm going to show you how we're going to use prime factors to do GCF, okay? So you would have been given in junior high, you would have been given numbers like 8, 16, and 20, and you would have been told, well, what's the greatest common factor of 8, 16, and 20? So how your teacher would have taught this in junior high is they would have said, okay, what are the factors of 8? So we did this in the first lesson as well. 1 and 8, 2 and 4. Those are the factors of 8. What are the factors of 16? 1 and 16, 2 and 8, right? Those are factors of 16. And then if you divide 16 by 4, you get 4. So the factors of 16 are 1, 2, 4, 8, and 16. Then you would have done, okay, what are the factors of 20? So 1 and 20 are factors of 20. 2 and 10. 3 does not work. 20 divided by 4 is 5. Those are the factors of 20, right? And then they would have said, okay, well, what's the greatest common factor? So 1 is a factor, but there's a factor that's common in all three that's greater than 1. 2 is a factor. There's a factor, though, that's greater than 2 that's common. The answer is actually 4. So 4, 4, and 4, it's my greatest common factor of 8, 16, and 20, right? Um, 8 is not the greatest one. It would be, except 8 is not a factor of 20, right? So the greatest common factor is going to be 4. Now, it sounds really easy, right? Like how you did it in junior high. What's going to happen though in high school is I'm going to give you much bigger numbers than 8, 16, and 20. And it's not going to make sense to write the factors. It's going to be easier to do the prime factorization, okay? So what we're going to do is we're not going to do class example number 1 because these are small numbers and you could do this method here, which is technically what we did in grade 9, right? I want you to do the new method, which we're going to do in grade 10, which is prime factorization. So when we're doing GCF in grade 10, you're going to use this concept called prime factorization to determine the greatest common factor, okay? So prime factorization, it's what we've done, right? You break down the numbers by the prime factors. Okay, so let's do what we've always done. So 90 divided by 2 is 45. 45 is not divisible by 2. So if we jump up to 3, we're going to get 15. And 15 divided by 3 is 5. So I want you to rewrite 90 as a product of the primes. So 90 is the same thing as 2 times 3 times 3 times 5. Okay, now we're going to do the same to 225. 225 is not divisible by 2. Okay, so I'm going to check 3. And 225 is divisible by 3. Like if you check on your calculator, 225 divided by 3, we get 75. Okay, 75 divided by 3, so 75 is divisible by 3, and we get 25. 25 is not divisible by 3, but it is divisible by 5. So this is the prime factorization of 225. 3 times 3 times 5 times 5. Okay, so what you have to do in order to get the GCF is you first need to rewrite the numbers, the prime factorization of each number. Then what we need to do is I want you to star this. What it says is to determine the GCF of new numbers, we find the product of each prime factor, including repeats, which is common to each prime factorization. So this doesn't really make sense, but I'll show you in the example. So we're going to find the product of each prime factor, including repeats, which is common. So what that means is I want you to circle all the numbers that are common to both. So for example, I can't circle a 2 because there's not a 2 here. But look at, I could circle these 2 3s, right? If it's common to both, circle it. I could circle this pair of 3s because remember it said including repeats. And can I circle a pair of 5s? Yes. I could either circle those 2 or these 2. It doesn't matter as long as you circle a pair. Then what you do is you take out, it says you're going to find the product of those numbers. So these 3s, I'm going to take out a 3, and a 5, and the product of those numbers means you multiply. So 3 times 3 times 5 is 45. So the GCF of 90 and 225 is 45. Okay. Um, let's do B, and then it should start making sense. Okay, so let's do B together. 154. So let's break this down by a product of primes. Divide that guy by 2, and you'll get 77. Now, 77 is not divisible by 2. It's not divisible by 3. It's not divisible by 5. When you divide it by 7, the answer is 11. And then I stop because 11 is a prime number. So 154 is equal to 2 times 7 times 11. Let's do 198, okay? So 198, let's check what that is divided by 2. So 198 divided by 2 is 99. Let's divide that by 3 to see what we get. 33. Okay, so 198 divided by 2 is 99. Divide that guy by 3 and we get 33. Divide that guy by 3 and we get 11. 198, rewritten as a product of the primes, is 2 times 3 times 3 times 11. Now what we have to do is we have to circle the prime factors that are common to each. So I hope you see that that 2 I could circle because I've got it, it's common to both. And any numbers I could circle, that guy there. Those are the only 2 numbers that are common to each. So we're going to take out a 2, we're going to take out 11, and the answer is those 2 numbers multiplied. So the GCF of 154 and 98 is 2 times 11, and that is 22. That's what the GCF is. Okay. Flip your page, and we're going to do these 2. Okay. And we're going to find the GCF of them, and then I'm going to give you some homework questions. Now, here's what we're going to do. I'm going to speed this up a little bit for you. It says use prime factorization. I think that you guys are now really good at breaking these numbers down. Now what you just need practice on is can you figure out the GCF, right? So I'm going to actually give you the prime factorization of each number because I know you know how to break it down. Like you'd be able to do that on a test. So I want you to write down 245. The prime factorization of 245 is 5 times 7 times 7. If you want to do break it down and check my answer, you could definitely do that. Or I'm just going to give you this work for now. 315, if you broke that down by the factor tree, we would get 3 times 3 times 5 times 7. And the last one is 770. So if you broke that guy down using the factor tree, you'd get 2 times 5 times 7 times 11. Okay, how do we do the GCF? We have to circle the numbers that are common to all 3. So like I'm going to look here for a 5. There's a 5 and there's a 5. So I could circle this group of 5s. It's got to be common to all 3. Then like the 7, 7, 7, 7. Do you guys see that? So I could circle those 7s. It kind of looks like 71. It should be 11. So let's circle 3 7s. And again, some students will say, well, Mrs. King, does it matter if I circle this 7 or this 7? No, it doesn't matter. I could do like, I'm going to do this group, let's just say. Okay, so circle this guy. Now, any other numbers that are common to all 3, and there isn't, right? There's a 2 here, but I would need 2's up here. So I can't circle any 2's. I can't circle any 3's because this guy would need a 3 and this guy would need a 3, right? So that's it. And for every group that you circle, you always take out one number. So take out a 5 and take out a 7. The GCF of, I'd like you to tell me what numbers you're taking the GCF of. 245, 315, and 770 is 5 times 7? And what's 5 times 7? 35. That's your answer. Now, some students are going to be like, four numbers, I got to find the GCF of this. Yeah, super simple. Do your factor tree for each one. I'm not going to get you to do that. I'm just going to give you the numbers and see if you could figure out what the GCF is. So let me give you the prime factorization of 171. So write down 171 is 3 times 3 times 19, right? 19 is a prime number. That's why I stopped at 19. Okay, 285. What's the prime factorization of 285? 3 times 5 times 19. Okay, what's the prime factorization of 399? 399 is 3 times 7 times 19. What's the prime factorization of 1140? If you broke it down as a product of the primes, 2 times 2 times 3 times 5 times 19. Okay, we got to circle what's common to each. So let's see. I've got a 3, a 3, a 3, and a 3. I could circle that. It's got to be common to each number. Now, 3, nope. 5, I got 5 and 5 here, but I need a 5 here, so I can't circle 5. Do you guys see any other number that I could circle? Right here. So my answer, the GCF of that guy, that guy, that guy, that guy, the greatest common factor that I could divide out of all of those numbers is 3 times 19, and 3 times 19 is 57. Okay, 3 times 19 is 57. So what I want you to do, this is going to be the end of part 1. I want you to do these questions here, which we'll circle in our homework. These are going to be GCF questions, and they start on page 11. Then I want you to make sure you mark your homework, right? So at the very end of this lesson, at the very end of the homework, you'll always have your solutions, right? So at the very end of lesson 2, they're going to give you your solutions. So you're going to how I always tell students to do it is you do one question and then you mark it, okay? So I want you to do, let's see, 1, 2, 3, B, C, E, 4A. So let's go ahead and circle those. So question 1, you could do the grade 10 method or you could do the grade 9 method for number 1. Number 2, you're doing the GCF and it wants prime factorization. So you're doing the grade 10. Remember, write down your prime factors, 2, 3, 5, 7, 11, 13. Break down 150, start with the number 2. Break down 420, start with the number 2. And you're going to rewrite each number as a product of the prime factors. And then you're going to circle the numbers that are common to each, remember, and you multiply them together. So do number 1, do number 2, do number 3. I want you to do for 3, B, C, and E. And I want you to do number 4A. And remember, the other resource that you could always look at is on the Google Classroom. You could open up lesson number 2 and you could scroll down to the homework. And remember, they do their factor trees slightly different than me, but they've got the work done here, right? And that's the end of part 1. When you're done that homework, you could watch part 2 and we'll do lowest common multiple.